walang makahahadlang, walang maiiwan. Sama-samang lilipad, kamtin ang pangarap. Sa hamong kinakaharap, patuloy na aangat. Edukasyon para sa lahat, sulong edukalidad. Ito ang Masinloc School on the Air at mapakikinggan sa Serbisyong Putog Radio, DWSP 101.5 News FM.
Good day, dear grade 8 learners. I am Sir Mark A. Seplaco of Santa Rosario Integrated School, and I am your teacher facilitator throughout this lesson. Today, you are going to join me in our topic in Mathematics 8, Quarter 3, Module 6. Before we begin, be sure that you have your pen, paper, and your module with you. Our topic for today is applying triangle congruence to construct perpendicular and angle bisector. Prepared by the learning competency covered in this lesson is applies triangle congruence to construct perpendicular lines and angle bisector. The objectives of this lesson are: 1. Apply triangle congruence to construct perpendicular bisectors and angle bisectors. 2. Apply theorems on perpendicular bisector and angle bisector and proving congruent angles and segments in a triangle. And last, solve problems related to perpendicular bisector and angle bisector. Before we proceed with our lesson, let us refresh your knowledge about triangle congruence. Let us try to recall some of the terminologies that we may encounter with this lesson. For 30 seconds, identify the given figures or symbols. Time is up. These are the answers. Number 1, congruent. Number 2, perpendicular lines. Number 3, midpoint. Did you get all the correct answers? Very good. Now, you are already familiar with the different terminologies that we may encounter with this lesson. Let us proceed to the next activity. One summer, EJ attended the Saranggola Festival in Pandi, Bulacan. She notices that the spars of the kite produce multiple congruent triangles. Let us help EJ to identify the different congruent triangles in the kite. Identify at least 3 pairs of congruent triangles. 1, 2, and 3. Time is up. These are the possible answers. Triangle AOB is congruent with triangle AOC. Triangle BOC is congruent with triangle COD. Triangle ABD is congruent with triangle AC. Did you get all the correct answers? Very good. In each figure, congruent parts are marked. Give additional congruent parts to prove that triangles are congruent and state the congruence theorem. Number 1, number 2, and number 3. Time is up. These are the answer. Number 1. Segment ON is congruent with segment OM. That is hypotenuse leg theorem. Number 2. Segment SI is congruent with segment IS. That is also hypotenuse leg theorem. Number 3. Segment BO is congruent with segment BO. That is leg-leg theorem. Did you get all the correct answers? Very good. Remember, class, that the different postulates and theorems in triangle congruence are SAS postulate, which means side angle side. ASA postulate, which stands for angle side angle. SSS postulate, which means side 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 postulate. And the last one is the AAS theorem, which stands for angle angle side theorem. Now that you're already familiar with congruence postulates and theorems, you are now ready to apply them. We can prove other theorems by using triangle congruence. Let us see how. Directions: supply the missing statement and the two-column proof. Given, line BD is the perpendicular bisector of segment AC. We need to prove that segment BA is congruent with segment BC. Remember, class, that in writing the two-column proof, statements should be connected with one another until we come up with the last statement, which is the statement to prove. Our first statement is line BD is the perpendicular bisector of segment AC. Our reason for that is given, since it is already given. 2. The next statement is segment AD is congruent with segment CD. Since line BD is the perpendicular bisector of segment AC, therefore, it divides the segment into two equal parts. Our reason for that is the definition of perpendicular bisector. The next statement is angle ADB and angle CDB are right angles. Since perpendicular lines create a 90-degree angle, therefore, our reason is the definition of perpendicular bisector. From our statement number 3, we can come up with the statement angle ADB is congruent with angle CDB, since they are both right angles. Our reason is any two right angles are congruent. In our statement number 5, we can come up with segment DB is congruent with segment DB. Our reason will be reflexive property. Since they are two pairs of sides are congruent and a pair of angle are congruent, we can come up that triangle ADB is congruent with triangle CDB. Our reason for that is SAS congruence postulate. So therefore, segment BA is congruent with segment BC. The reason for that is the CPCTC, which means corresponding parts of the congruent triangle are congruent. Now, let us formally state that the perpendicular bisector theorem is if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The converse of the theorem is also true, stated that if a point is equidistant from the endpoints of a segment, then the point is on the perpendicular bisector of the segment. We can also use triangle congruence to prove it. Below is a proof of the converse of the perpendicular bisector. Given, segment CA is congruent with segment CB. The hint, we need to construct a line through C perpendicular to AB. We need to prove that C is on the perpendicular bisector of segment AC. Statements and reasons are two-column proof. Number 1 statement is the segment CA is congruent with segment CB. Another, segment CD is a perpendicular bisector of segment AB. The reason for that is given. From that statement, we can come up with another statement, which is angle ABC and angle BDC are right angles. Now, the reason for that is definition of perpendicular lines. Angle ADC is congruent with angle BDC. Since they are both right angles, our reason for that is all right angles are congruent. The next statement is segment CD is congruent with segment CD. They are both the same, so therefore, the reason for that is reflexive property of congruence. The next statement is triangle ADC is congruent with triangle BDC. That is the hypotenuse leg theorem. The next statement, segment AD is congruent with segment BD. The reason for that is the CPCTC, which stands for the corresponding parts of congruent triangles are congruent. And the last statement, which is C is on the perpendicular bisector of segment AC. The definition or the reason for that is the definition of perpendicular bisector. Let us study the illustrative example. Number 1, in triangle ABC, what is segment BC if segment AB is equals to 10? The solution for that or the answer, using perpendicular bisector theorem, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Then, segment AB is congruent with segment BC. Since AB is equals to 10, therefore, segment BC is equals to 10. Number 2. In triangle LAS, line AO is perpendicular to segment LS. What is LO if segment OS is equals to 7? Using converse of perpendicular bisector theorem, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Then segment LA is congruent with segment SA. And segment LO is congruent with segment OS. Since segment OS is equal to 7, therefore, segment LO is equal to 7. Number 3. In triangle SUT, line L is perpendicular to segment ST. What is segment SB? Using perpendicular bisector theorem, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Then SB is equals to VT. 2x minus 8 is equals to x plus 5 using the substitution. 2x minus x is equals to 5 plus 8. That is the subtraction property of equality. Then when we do that, x is equals to 13. We need to substitute SB is equals to 2x minus 8. SB is equals to 2 times 13, which is the value of x minus 8. SB is equals to 26 minus 8. Then segment SB is equal to 18. Now that we are done with lesson 1, Applying triangle congruence to construct perpendicular bisector, we will now proceed to Lesson 2, Applying triangle congruence to construct angle bisector. During the Saranggola festival, EJ was able to look closer at the kite. Is she able to see angles being formed at each of its corners? In the figure, we can observe that segment BC has divided angle B and angle D into equal parts. It is called angle bisector. Let us try activity if you still remember the congruence, triangle congruence. Directions. In the given congruent triangles, identify the congruent angles by using special markings. Number 1. Triangle LEO is congruent with triangle VEO. You need to identify at least 3 angles. Number 2. Triangle ABC is congruent with triangle ABC. Same with number 1. You need to identify at least 3. Time is up. These are the answer. Number 1. Angle L is congruent with angle B. Angle LOE is congruent with angle VOE. Angle OEL is congruent with angle OEV. Number 2. Angle B is congruent with angle D. Angle BAC is congruent with angle BAC. And angle BCA is congruent with angle BCA. Did you get all the correct answers? Very good. Directions. Supply the missing information to complete the proof below. Given, segment LO is congruent with segment VO. Angle LOE is congruent with angle BOE. We need to prove that segment OE bisects angle LEB. Using the 2-column proofs, we have the statement and the reason. Our first statement is segment LO is congruent with segment BO. That is given. Another is angle LOE is congruent with angle BOE. That is also given. From that statement, we can come up that segment OE is congruent with segment OE. The reason for that is reflexive property. The next statement, triangle LOE is congruent with triangle BOE. Since we have 2 segments or 2 sides are congruent and 1 angles are congruent, therefore the reason for that is SAS postulate. Number 5, angle LEO is congruent with angle VEO. The reason for that is CPCTC or the corresponding parts of congruent triangles are congruent. Then the last statement, which is the one we need to prove, that is segment OE bisect angle LEB. The reason for that, if a ray divides an angle into 2 congruent angles, then it bisects the angle. Then the angle bisector now is a segment, ray, or line that divides angles into 2 congruent parts, congruent angles. We have to study the illustrative examples. Number 1. In triangle DAB, segment AC is the angle bisector. Therefore, angle BAC is congruent with angle BAC. If the measure of angle DAC is 50 degree, then the measure of angle BAC is also 50 degree. In triangle MAE, angle MAH is congruent with angle PAH. If the measure of angle MAH is equals to 2x plus 5 degree and the measure of angle PAH is equals to x plus 25 degree, what is the value of x, the measure of angle MAH, the measure of angle PAH, and the measure of angle PAM? First, we need to solve for the x. Using the substitute of the given, angle MAH is congruent with angle PAH. 2x plus 5 is equals to x plus 25. Subtraction property of equality, we have 2x minus x is equals to 25 minus 5. The answer for that is x is equals to 20. Substitute x is equals to 20 to find the measure of angle MAH and the measure of angle PAH. The measure of angle MAH is equals to 2x plus 5. The measure of angle MAH is equals to 2 times the value of x, which is 20 plus 5. The measure of angle MAH is equals to 40 plus 5. Therefore, the measure of angle MAH is equals to 45 degree. As the same process, the measure of angle PAH is equals to x plus 25. Substitute the value of x, which is 20, plus 25. Then the answer is the measure of angle PAH is equals to 45 degree. Since the measure of angle MAH is equals to 45 degree, the measure of angle PAH is equal to 45 degree, and the measure of angle MAH plus the measure of angle PAH is equals to the measure of angle PAM. Therefore, the measure of angle PAM is equals to 90 degree. Once again, this is your on-air teacher, Teacher Mark A. Zaplaco of Santo Rosario Integrated School.